Okay, so 17b is what I want to try here. Um, and when you first look at it, there's not a ton you can do with this thing. Um, the hint is actually what gives this a problem away. This the strategy for this one. You're going to need to factor, which means you're probably going to get some sort of quadratic in there. And if you're going to get a quadratic, you want to get. It's kind of like make cosine your x so that you end up with something like cos squared x or cos squared t in this case plus 2 cos t plus 1, something like that equals 0. And then this is really like an x squared plus 2x plus 1 equals 0 problem, and then you can factor that. So let's play with this and see what we can end up with. Now I've got a sine term on the right and a cosine squared term on the left. Cosine squared, remember sine squared and cosine squared are related in that if you add them, they always have to be 1. So this is the same thing as saying 2 parentheses 1 minus sine squared. Now if I work this out, I get 3 sine t equals 2 minus 2 sine squared t. And if I get everything over on one side, I've got 2 sine squared t plus 3 sine t minus 2 equals 0. So you can think of this kind of like 2x squared plus 3x minus 2 equals 0. We need to factor that. Well, you can factor it over here if you like working this way better. So one of them's got to be a 2x and one's got to be an x. There has to be a plus and a minus in here somewhere. And you need to use a 2 and a negative 1 or a 1 and a negative 2. So if I put plus 2 here and minus 1 there, that's 4x minus 1x gives me 3x, and then I've got negative 2 for my units. So this will work. But really, it's not x, it's sine t. So over here I get 2 sine t minus 1, parentheses, whoops, not x, sine t plus 2 equals 0. And now I can set each of these parentheses equal to 0, so 2 sine t minus 1 is 0, or sine t plus 2 equals 0. So let's solve the one on the left here. If I isolate sine, I'm going to get 1 over 2. And if I think about where on the unit circle this happens, it's going to be a height of 1 and a radius of 2. This angle right here has to be 30 degrees. So t equals 30 degrees. But it's not just 30. It's also over here at 150. So t could also be 150. And it's not really just those, because it can happen every 360 degrees. So plus 360k, plus 360k, and k is any integer. Right? You could do this in radians, and then you would get t equals pi over 6 plus 2 pi k, or t equals 5 pi over 6 plus 2 pi k, where k is in z. We still have this part over here. So sine t in this case would be negative 2. If you try to use your calculator to do sine inverse of negative 2, you're going to get an error, and the reason is, remember, sine has to always be between negative 1 and 1. So this one doesn't give any answers, right? So no solutions for this part. So really all of our solutions are right here in radians, or right here if you're working in degrees.